Have we lost Kris? She's not back. Oh well. Now we could. Oh, here we go. You're back again. I wasn't sure. Did you want me to do your presentation or?
No. Well, I know you offered this morning, but no, that will be unnecessary. Thank you.
Fair enough. How are you doing this morning? That looks delicious.
I am drinking my coffee because, as I said, it is 7:07 a.m. So I don't know why I agreed to this, really. I really wanted to speak at NDC for years, and so time zones be damned, really.
Yeah, but just think how much you get out of the day. So now you get this out of the way, and you got the whole day to enjoy the post-presentation high.
I got a full day of work after this.
Oh, right. Okay. All righty.
All right, so I did share. Can you see that now? Yes, nice.
Fantastic. So there is knitting in this, and I promise you all, this is not a talk to miss.
There's always knitting within arm's reach of me. You know.
Exactly. Just you did once knit the genome of a certain virus, did you not?
Oh, it's around here somewhere. I didn't quite finish it. You know, the original thought was I was going to knit the genetic sequence of the COVID virus last year when we first went into lockdown, and yeah, I thought I'll knit it throughout lockdown. Gave up on that pretty quick. Glad I did. I've still got it. I'll finish it one of these days.
Yeah, and then you can just cover the whole building probably. It'd be enormous.
Yeah, I worked out the math. It would be like several football fields, just the section of it that I had.
Oh, dear. All right, well, we better get to this talk then so you can go back to knitting.
Yeah, that'd be great.
All right, no worries. I'll see you after.
Okay, cool. Well, good day, everybody. God, it's been a while since I've said that. Thank you so much for having me. You know, for those of you who don't know me, as Lars said, my name is Kris. I'm an American Australian. Thank you. I do have 2 passports. If you want to tweet at me, my username's at web_goddess. They're in the corner. It should be on the corner of my slides. Yeah, cool. Yeah, so I've spent the majority of my tech career in Sydney working for companies like 9 Digital and Canva and then AWS. But yeah, last year, Rad and I decided it would be fun to move to Europe for a while. So yeah, that was complicated, but we did get to Munich in August. And nowadays I'm a manager in the AWS DevRel team. It is 7 a.m. here. I did mention that, but as I said, I've always wanted to speak at an NDC event, so I'm not going to let moving halfway around the world stop me. So in my career, I've been a web developer, a BA, a tech evangelist, a people leader, but what I have not been is a machine learning expert or a data scientist. But it's a topic that interested me, and maybe like you know, I'd see talks at meetups and at conferences over the years that I kind of hoped would show me an easy path to get started. I actually remember attending one developer conference in Sydney, that where I went to a talk that was billed as machine learning for software developers, and I got there and it was a full room, and I'm very excited. And within 5 minutes, literally, it was slides of nothing but calculus. And I remember looking around the room at the other people who were looking at me, and we're all like, this is a bait and switch. Like, did you know that was what it was going to be? I didn't actually get much out of that talk. So don't get me wrong, though. If you actually want to get a job as a machine learning expert or a data scientist, you need to have that foundation. You need to do the calculus. Absolutely go back and do that. But this talk isn't aimed at you. This talk is for folks like me who were curious, who were interested, who wanted to do something practical and just starting out, and do it as simply as they can. So I promise you no calculus today. I just want to have some fun, show you some of the things that inspire me about machine learning, and show you a project I've been working on. Hopefully get your juices flowing and get you to do one yourself. So this is what we're going to cover today. I'm going to cover some of the cool stuff people are doing in AI ML, some of the stuff that's personally really exciting to me and is maybe outside of the examples that you see normally when people talk about this stuff. I'm going to talk just a little bit about how you can get started, a couple few resources. I'm going to briefly cover the AWS machine learning stack. Not really trying to do you a sales pitch here, but it's kind of relevant to understand some of the tools I'm going to use in my project. We have different tools that cater to different levels of expertise, basically. And then I will show you this project I've been working on, which, you know, Lars sort of gave you the hint there. It's about knitting. It's an attempt to teach a computer to reverse engineer knitting patterns. And no, you don't need to know anything about knitting for that part. Okay, so state of AI/ML. Like every week there is some new breakthrough. There's a new video of robots dancing to some song, or defeating the world champion in the game of Go, and those are all fine. But one that's particularly relevant to me and to all of you right now was the success of DeepMind's AlphaFold 2 at the 14th CASP competition, and that stands for a really long acronym that I can't remember because it's 7 a.m. But the goal of this competition is to use AI to predict the structure of proteins. And proteins are made from a really long ribbon of amino acids, and it sort of folds itself up into twists and turns and tangles. And the structure of a protein determines, what it does. But there's an astronomical number of shapes that each sequence can fold itself into. And researchers have been grappling with this challenge literally going back to the 70s for 50 years. But at last year's competition, end of 2020, AlphaFold predicted the structure of dozens of proteins with a margin of error of 1.6 angstroms. That's 0.16 nanometers. That's atom-sized. This is a massive, shocking achievement. Like if you read news articles about this, like other researchers in the field are like, this is a big deal. And it's going to help researchers understand diseases, design new drugs. So as an example, what you see here in the slide, the actual molecule is in green there, and the predicted structure is in blue. And it's, it's not perfect, but it's pretty close. And incidentally, of course, this protein happens to belong to coronavirus and is implicated in immune evasion. And even more massively, just a few weeks back, DeepMind published the paper and the source code for AlphaFold. It's actually on GitHub. You can go look for it. And they also released predictions for the shape of every single protein in the human body, as well as proteins for like 20 additional organisms that scientists often use in their research. So far, I just looked it up last night. They've released 350,000 newly predicted protein structures. Of course, not all of them are accurate. They're predictions, but it's a really good start for scientists. And they say they'll predict and release the structures for 100 million more in the next few months, more or less all proteins known to science. So that's an example of AI solving really serious problems important to me and you, and that's awesome. But let's look at some less serious examples. The other area that I really love is using machine learning to generate art. If any of you went to LinuxConf 2018, when it was back in Sydney, I actually organized one of the mini confs that day on art and tech. And I had a whole day with speakers around. We had someone from talking about procedurally generated landscapes, using music that they'd written. We had someone talking about NaNoGenMo, National Novel Generating Month, which happens every year and is where people try and create a machine learning model that can use code to write a 50,000-word novel. I remember Boing Boing described one attempt as surprisingly plausible. But so one of the early techniques that artists really jumped on back in 2014 was called Deep Dream. And you may have seen this. The gist of it is you have this convolutional neural network represented by this very simplified diagram here. And you've trained it to recognize different animals and objects like dog and cat and mouse, all those labels, those output classes on the right. So then if you give it an image of a puppy, like this little puppy here as an input, what you expect to see is that the corresponding output neuron for the dog class, that lights up. That's why it's yellow. Now, suppose that we give it an input that it's not trained on, some animal that it's not trained to recognize, like a jellyfish. So what we can then do is try and make a series of modifications to this image of the jellyfish to try and get the dog neuron to fire. And after several such iterations, you get something like this. You actually get recognizable dog parts like snouts and legs. And there's some really cool, very dreamlike art that's been created by this method. In 2016, neural style transfer sort of exploded. You may have seen that Prisma AI app that everybody was using for a while on Instagram. The technology behind this is to separate the elements of an artistic style from the underlying content. So you can sort of like cut and paste the style of one image onto another. So I actually went to a TensorFlow workshop at the Google Sydney office back in 2017 and learned about this. And so I have this is a picture of my husband out on Phillip Island, actually, with a horse. And I've applied the style of different paintings, which is pretty cool. Another big breakthrough was the development of generative adversarial networks, or GANs. You've probably heard of this, where systems can generate realistic-looking fake images that don't actually exist in real life. You know, there are horror stories everywhere about, I think it's These People Do Not Exist, where there's all these people who are not real. They're completely computer-generated. But forget people, this is the internet. I want you to go to the website TheseCatsDoNotExist.com, which does the same thing, but for cats. And this was built using the popular StyleGAN on Amazon's SageMaker. And some of them are virtually indistinguishable from reality, while others of them are a little bit more nightmare fuel, that one in the upper right there. But the application of GANs don't need to be limited to just photorealistic output. So this is a piece designed by my friend Jay Rosenbaum. Some of you may know Jay. Jay is an artist living in Melbourne, and Jay keynoted at that Art and Tech mini conf I did. They also keynoted at, I believe, DDD. Was it DDD Melbs a few years back as well? So Jay works with 3D modeling, with AI, ML, with extended reality technologies. And Jay created these artworks last year during the initial COVID lockdown in Melbourne, the big one. And started with drawings of faces and bodies, and then had a neural network generate a landscape from the sketch. The series is called The Isolation of Being. You should check it out. It's really sorry to see you guys are back in lockdown again. And this is one of the magical machine learning use cases I love the most: getting pizza to people faster. Domino's Pizza, and I don't know if you know this, there are different Domino's franchises around the world, but Domino's Pizza Enterprises Limited is the biggest Domino's franchise holder. It represents Domino's back there in Australia. I think headquarters might be in Brisbane. Also randomly here in Germany, where I live now. But so even before the pandemic, you know, Domino's had 70% of their orders coming from online. And so they did a lot of study of this data and basically made the surprising connection that if they could get pizzas to people faster, they were more satisfied with their meal. So back in 2019, they launched a project called Project 310. It was an initiative that aims to have a pizza ready for pickup within 3 minutes or safely delivered within 10. So some of the stuff they did that, you know, they had more efficient cooking methods and transportation. They physically opened stores closer to where customers live. But also they used predictive technologies to help reduce pizza making and delivery times. So they built this system, and I believe there's talks about this and a case study online if you want more details, but they used Amazon S3 as a data lake and Amazon SageMaker to build machine learning models. And basically the stores that have this heads up display where, as you know, they can see at any time the likelihood of certain pizzas being ordered, and they can start making them ahead of time. So they're actually coming out of the oven just as Lars gets the urge to ring up and order his Hawaiian pizza. And at one store, they actually managed to get delivery times down to just like 5 minutes. So that's amazing. Okay, so for me, the current interesting stuff happening in AI ML is art, it's cats, it's pizza, and you know, the survival of the human race. And I don't know about you, those are pretty much the only things that I can actually concentrate on these days. And they're personally more impactful and meaningful and inspiring to me than dancing robots or self-driving cars or ever more realistic chatbots. You know, P.S. Please, everybody get vaccinated. I want to come visit again. So hopefully this has you feeling more inspired. And if you are, you know, you might be wondering how to get started. There's a lot of material on this, obviously a lot of courses and stuff like that. But one resource I can recommend, just part of the day job here, AWS's Ramp Up Guide for Machine Learning. It's on our website. It links to the free resources and training courses that we have that you can use to start building your skills. Back in February, we also did an online event called AWS Innovate. It had more than 50 sessions about the latest innovations in AI ML, business use cases, architectural best practices. So if you Google AWS Innovate, I believe you can actually still register and watch those sessions on demand if you missed it. Okay, I'm briefly going to talk about AWS's machine learning stack here. Not a sales pitch. It will actually help a little bit when I go into my project to understand sort of the different types of tools that we have. But really, AWS has a lot of tools because our mission is to put machine learning in the hands of every developer, every software developer. How do we do this? We do that by building a lot of different AI ML services that cater to different skill levels. And I know this looks like a ton, and actually it's probably out of date already. There's probably more, but it's roughly 3 layers. We got frameworks and infrastructure there at the top. We got machine learning services in the middle, and we've got AI services at the bottom. So just in real brief, what that means. Those AI services at the top, and I am going to use one of those in my project. This is where models are largely pre-trained for you. And you just access predictions basically with an API call. So we've got like image recognition of like basic everyday stuff. We've got natural language processing, speech to text, text to speech. And actually at reInvent last year, you see all those new labels. We launched a new suite of anomaly detection tools under the Amazon Lookout brand. In that middle layer there, we've got what we call machine learning services, which basically for the most part means Amazon SageMaker. So we've got an IDE called SageMaker Studios. It's got all the tools that you need to develop, train, debug, deploy, monitor machine learning models. I'm going to make heavy use of this in my demo. And as you can see from all those new labels, again, we're bringing out a lot of new features for this every year. And lastly, down there at the bottom, if you want to roll your own, if you're an expert, of course, we have the foundational options in the frameworks and infrastructure layer. This is where you can launch a deep learning AMI or a container on whatever hardware you need and manage it however you want. But I'm not going to demo that part because, again, not a machine learning expert. And that brings me to my project. So when I am not messing around with computers or looking at cats that do not exist on the internet, as Lars said, I am often knitting. I took it up as a hobby, actually, when I first moved to Australia many, many years ago. I've been doing off and on ever since. In fact, when we were, I do have knitting right next to me, always have it next to me. When we were in lockdown last year, and we were in lockdown for 5 months, by the way, last winter, I actually started live streaming my knitting on Twitch, which, no joke, I've got 123 followers for my knitting live stream. So knitting_with_Kris, if any of you want to follow me, or you can watch like 30 plus previous episodes on my YouTube page. But because you all know me as a knitter, all these geeks in tech, sometimes I get tagged on tweets like this. And so this is a real tweet from last April, just like, a few months back, actually. It turns out this guy's mother turned one of his favorite jumpers into a couch cushion. And he wanted to see if the original jumper could be recreated. And of course, in the replies, somebody jokes, there's got to be an app for that. But actually, and I did comment in the thread, for an experienced knitter, this is not an uncommon thing to do. This is a photo I took in the AWS kitchen back in Sydney in 2019, not long before I was thinking about moving to Europe. This is my colleague Mega. She's wearing this beautiful blue jumper, and I'd never seen this stitch before. I'd never seen this particular design, and I took a photo of it because I'm a knitting dork, and that's what I do. I've done it on the bus. But if I look at this, I can tell you that the background there is what we call reverse stocking stitch. That's the sort of background part. Those raised zigzag lines, those are made up out of 3 knit stitches, and they use a combination of increases on one side and decreases on the other, and that's why you get the slant. And some of that I get just because I can recognize the texture of what reverse stocking stitch looks like. And some of it is knowing how stitches work, especially if you've got a good image or you're looking at something, you can zoom in and read it stitch by stitch, almost like deciphering cursive handwriting. And so, yeah, that's literally reverse engineering. It's taking a man-made object and studying it to deconstruct its design. And of course, we do this all the time in technology and software engineering. But turns out, if you didn't know it, knitters love doing it too. So that's what got me thinking about 2 years ago about this problem. Like if a skilled knitter can reverse engineer a pattern from a finished knitted object or even just a picture of a knitted object, why couldn't I train a computer to do it? Turns out I am not the only one who has had this idea. This is a paper that was presented at the International Conference on Machine Learning in June 2019. Right after I started this project, I reached out to an AI/ML expert at AWS. She's like, oh yeah, somebody's already working on that. So the goal of these researchers was to take a photograph of knitting, reverse engineer the pattern, feed that into a knitting machine, because that's also a thing. A lot of the jumpers you buy in stores are machine knit on knitting machines, and get an identical swatch back out. So they're basically trying to build a knitting replicator, a duplicator. But they recognized pretty early on in the project that one problem is that photographs of knitting suck for computer vision, to be frank with you. Because knitting, it's floppy, it's stretchy, it's depending on the yarn, it's often fuzzy and hard to see. So they had a breakthrough, and their breakthrough was to use both, yes, real knitted swatches in there, and a swatch is a piece of knitting, real knitted swatches in their training data, but to actually augment that with simulated knitting as well. So those industrial knitting machines I mentioned, a lot of them have really complex software that can actually simulate what the knitted fabric would look like. And they actually managed to get their hands on, these machines cost like hundreds of thousands of dollars, but they got their hands on the software and were able to generate lots and lots of swatches that they could use in their training data as well. And that gave much better results. And so the paper's online. It has a lot of calculus in it, and I promise you no calculus. But from what I can tell from the results, they haven't quite cracked it yet. They're getting close. Back then, they were about 80% accuracy in their experiments, and they used both adversarial and generative. They used both convolutional and generative adversarial neural networks. So no, there's not an app for it yet, but we're getting there. And so I decided to try it for myself. I'm drinking my coffee still. All right. So rather than output, though, on reading a pattern stitch by stitch, like I said, like reading cursive handwriting, I decided to descope, of course, make it simpler, treat it just to start as an image classification problem. So that's where you take an image as an input and you output a class label. It's that slide I showed you with the puppy going to the puppy label. So like how with my brain, I can recognize the texture and know that that's reverse stocking stitch and that's garter stitch. I just wanted to build a machine learning model that could do the same. So this was the plan as I saw it. I'd get some training data. How hard could that be? Label it, train a model, deploy it, maybe build a nice web front end for inference, and then dance on the grave of the knitting industry, problem solved. Again, had zero practical experience in machine learning at this point. All right, get training data. This is the first thing you learn. Everybody told me, when you start with machine learning, you will spend 80% of your time getting data and cleaning it up. And I was like, yeah, right. I can get that down. So I went and looked at what other researchers had done. If you've ever done this, you know that there are websites like Kaggle where you can download data sets. I couldn't find any knitting ones on there, but it turns out that the folks who wrote that paper I mentioned, they actually did make their training data set available. So they they used simulated data, but they also knitted about 1,000 pattern samples, really knitted them on that industrial machine in 5x5 grids. And they had this great idea to try and counter some of those problems I mentioned with the floppiness and the stretchiness. They knitted a grid into it, and they inserted steel rods into that to help it lay really flat and even for photography. But of course, as you can see there how they took photos of it. They realized that was not going to scale to the number that they were going to need. So that's when they hit on the simulation aspect. But you can download, there's their simulated data set here. It's these researchers at MIT. There's the URL. So I had to look through them. As you can see, they're little sort of different lace and different textural patterns. And I decided that was probably overkill for what I wanted. I wanted to just identifying like 5 basic stitches. I didn't need to go to this level. I was going to aim for, if you've ever knitted, stockinette, reverse stockinette, garter stitch, moss, and seed. These are just 5 very basic combinations of knits and purls. And so I thought, forget this. I'm going to collect my own data set directly from knitters. I don't know if you know this, there are a lot of us knitters online. We post pictures of our knitting, and I thought I can leverage this. I didn't want to spend hours like manually scraping and downloading pictures myself. So I thought I'll build some sort of a pipeline, a little application that would allow people to send me their images via email. So I'm not going to go through this in time. I've got no time in detail, but the idea, I built a little thing on AWS. The idea is that emails would come in with attachments. I would, check them for viruses and stuff. I would save it in an S3 bucket, and I had a database table where I sort of recorded the details of who sent me what. But the goal was to get them in S3 because I knew I'd need them there for my training jobs, and that saved me having to individually handle every image. So I got this working, and then, of course, I put out a tweet. This is the tweet I made. You may have seen it. You may have retweeted it. It did kind of go viral back in October 2019, asking for knitted samples. So I did write a full blog post. I talked about what I wanted, what I didn't want. I wanted images like this, where it was just a close-up of a particular stitch pattern. I also said what I didn't want, all the types of images I didn't want. I put the email address, and I put this out on Twitter. I also put it on Ravelry, which is like GitHub for knitters. And yeah, lots of people started sharing it. They started tagging in their knitting friends and forwarding it. I got a retweet and a reply from, Janelle Shane, who does that AI weirdness blog and newsletter, which she's like the rock star. So it was great. And more importantly, images started to arrive in the bucket. Random human beings around the world, random knitters, were actually doing the thing. It's working. And then I look in the bucket at the images, and they weren't all great. Sometimes people get excited, they don't read quickly, they don't read closely. They sent me stitch patterns I wasn't looking for, or they sent me pictures of whole garments, which are really beautiful, but don't really have the resolution I need to see the stitches. Sometimes they'd mess up and attach the wrong images. This one nice lady was like, I think I sent you Halloween candy. You did. So yeah, the first lesson is, even with the best of intentions, crowdsourcing your data is not the magic bullet. It is going to result in a lot of cleanup. And I'm not trying to shame or embarrass these folks. They were so nice. They were trying to help me out. But it did mean I spent a lot of time cleaning these images up. So I threw out all the dodgy ones. I cropped the rest the best I could to just show the stitch pattern. And then it was time to get them labeled. You actually have to label them so that you can feed them into the machine to train. And so rather than do it myself, I thought, again, I will turn to my fellow knitters. So one of the services we have in that middle layer of the AWS machine learning stack is called SageMaker Ground Truth. And it helps you build accurate training data sets for machine learning by coordinating public and private workforces. Basically, you set up a project in this little UI, and then you can put it out on Mechanical Turk and pay people to actually label your images. Or if it's a specialist sort of domain like knitting, you can actually set up your own workforce and give people a login so that they can log in and do it. So I did that. I put out the call for a volunteer task force, and I set up the job. And this is normally where I'd switch to the browser and show you, but I don't want to risk. I've got too much going on here. So I've just got some screenshots if you want to see what the Ground Truth interface looks like. Basically, down the left side there, I had some instructions that you can customize and showing, what they were looking for. It would give them a random image from the data set, and then it's got labels on the right. And that they picked the right option. And you see, I've actually got 6 options on there. I've got reverse stockinette stitched, stockinette, which is the back side of stockinette stitch, as I mentioned. I also added other, because I said people did send me some stitches that weren't in the set that I was after, and so other is used for anything other than those. And I also set this up. You can configure it so that every image had to be reviewed by at least 3 people to minimize the chances somebody would get it wrong or hit the wrong button. And that was a good thing because I quickly ran into problems without spending too much time on this. These are 2 of the stitches I was trying to review. This is garter stitch and reverse stockinette stitch. They look really similar. In real life, they don't, because one's the same on both sides and one's different. But in a flat photograph, I suddenly realized they're really hard to tell apart. I had trouble telling them apart. And so I realized that my labels for these 2 in particular were not going to be very helpful. 2 other stitches that I had that I wanted to identify were seed stitch and moss stitch, and they look very different. Thought that would be easy. And then I discovered that in British patterns, they use both words to refer to the same stitch, the one on the left. Only Americans call the one on the right moss stitch. So again, I realized that I was going to have unreliable labels for those 2 stitch patterns. So again, what's that? 4 out of my 5 are now useless. So time to descope even further. Can I just identify a single pattern? Can I identify stockinette stitch? Let's build stockinette or not. That's what I landed on. Time to train the model. Okay, so I showed you that slide of all the different tools we had. Back in 2019, that slide was a little bit simpler. And basically my best option to go with was Amazon SageMaker. That's that bit in the middle. It's a fully managed service that covers pretty much the whole machine learning workflow. You can use Jupyter workbooks, notebooks, all that stuff. But you can also do it directly in the console, which is what I did. Because remember, pretty much a beginner here. So I ran my training jobs on a single P3 instance, and that has GPUs to accelerate your machine learning jobs. And again, I would switch to the console here, but I'm just going to show you screenshots instead to save switching around. But basically, when you go to create your training job in SageMaker, you give it a name, you give it roles, you select which algorithm you want to use. It's got a whole bunch in there. I went with the one for image classification. And I was pretty much relying on some blog posts and tutorials that other people had done to show me how to do this. You set up your training data source. You can point it at your S3 bucket, which because I already had them in there, that part was actually pretty easy. You actually create both a training data set and a validation data set. Normally the rule is you use about 80% of your data set for training, and you set aside 20% of it that it will use afterwards to go through and gauge how accurate the predictions are. And so you just point it and tell it which bucket, and it'll work that out. And as you can see, it took me, reading up from the bottom, it took me about 7 attempts before I got a training job that actually completed. There's a lot of fields in the UI. I'm not an expert. I'm not going to lie. This is a tool that experts use. But I did finally get one that ran. Great. Time to test it out. So then you've got to deploy your model so you can host it in production so you can actually use it. This was the simplest part. You know, in SageMaker, you got to create an endpoint that takes a few minutes to be created. Then you can start passing images to it and getting classes back. As I said, like almost like calling an API. So this is, you can see I actually ended up throughout, I ran many training jobs, but I created, 3 different models. You've got to create an endpoint for an endpoint configuration pointed at a model, and then you create an endpoint that you can actually then have your code talk to. So then I wanted to build off something pretty so that I could show it off and test it out with a little bit of a web front end. So my colleague, Gabe Hollenby, who's at AWS in Singapore, some of you may know him, he comes out to Australia, or used to, pre-COVID, fairly regularly. He had this little React app he'd built that he helped me out with. He had the code up at the time. Only tricky bit, just side note, if you're doing this, SageMaker endpoints aren't exposed to the public by default. So I just set up a little Lambda function to act as the intermediary. Wasn't too hard. And so once that was done, I fired up my little React web app. I pointed it at the endpoint with that first trained model that I had. And I fed it the first image, which was a stockinette stitch. And oh my God, I got it right. I'm like, I nailed it. First try, right out of the gate. Great. Maybe I should try a second image just to be sure. That's not stockinette stitch. That's garter stitch. Oh crap. It got one wrong. So I'm thinking that's not good. I'll try something else. This isn't knitting. That's crochet. It's thinking these are all stockinette stitch. Something has clearly gone very wrong. So I tried one last image with a sinking feeling in my stomach. That's a cat. That is not stockinette stitch. So cancel my machine learning PhD. Turns out this is often the case with machine learning. It is extremely unlikely you hit the jackpot. I had to go digging in my logs, and I could see that my validation accuracy was 45%. It was like worse than a coin flip. So back to data cleaning and more training. So you saw in that screenshot, I ran lots of different training jobs, trying to figure out the magic combination of different options that would give me the right result. So to minimize the effects of image size and color, I wanted to rule those out. I cropped them all to a fixed size. I converted them to grayscale, so I got rid of the color information. I also rotated every image 90 degrees, which had the added benefit of doubling my sample size. So I think, yeah, I had 368 in that first lot. So I rotated them. I also added in clutter. I learned about this from someone. Clutter are images of the things you're not looking for, dinosaurs and accordions and airplanes. I found a set of these images that I could download online. And the idea is to train, if you train the model that everything you give it is knitting, it thinks everything in the world is knitting, like a cat. So you got to give it images of stuff that aren't knitting. That got my sample size up to about 900. And I also ran a hyperparameter tuning job, which sounds really fancy. But the idea is that, rather than me going in and trying out thousands of combinations, rather than me trying out, thousands of literally tweaking little hyperparameters, SageMaker has a thing where it will actually set up a job for you, a tuning job. It will try out hundreds of combinations and figure out the one that works best, like run a little competition. And so I did lots of jobs, as you saw. I will show you the best one that I got back in 2019 using SageMaker. Okay, so this is my little React app. I recorded this video to show you. And so I'm actually going to drag in, start the video. I'm going to drag in some images here. So that's stockinette stitch, and the prediction is stockinette stitch. So right away, okay, now garter stitch, not stockinette. This is better. This is already better. All right, drag in a few more. That's seed stitch. Again, not stockinette, as expected. This is some lace crochet, not stockinette. Brilliant. Our old friend the cat, also not stockinette. I'm feeling pretty good about the model at this time. So I gave this talk. One of the places I gave this talk was at Build Stuff Europe. And I actually ran around at the conference, and I would be doing this if I were with you and we were all together in Melbourne. I took pictures of people's sweaters on my phone and actually used them in the talk. And so these are actually samples of people who are at this particular conference. And it's getting these right. There is at least one that it gets wrong. I think, so these are all correct so far. I think the next one, and I might need to, it doesn't quite fit. I think I clear it and do it. There's one that it gets wrong. Like, it's not perfect. There's some images, this particular one, it gets wrong. It thinks it's stockinette. And you can see why. Stockinette stitch sort of makes little V's. That's kind of the characteristic I think of when I look for it. And this particular stitch, I don't know what this girl's sweater stitch was. It's probably a brioche or something like that. It's not stockinette, but it kind of looks like it. So I think that's why the model is calling that stockinette. But anyway, just to give you the stats, my validation accuracy got up to nearly 95%, which is pretty good considering, again, complete newbie at this. Now, you are probably sitting there thinking, yeah, Kris, you promised us simple. And that all sounds really complicated. You had to do 15 different jobs. You had to tweak hyperparameters. You'd be 100% right. You know, even with SageMaker taking on a lot of the heavy lifting, I still needed a lot of help from experienced folks to get these results. But I am happy to report that there are other options now. AWS is always innovating. And literally 1 month after I went through all of this, I saw this. We announced the availability of Amazon Rekognition Custom Labels. So Rekognition is one of those AI services at the top layer of the stack. Out of the box, it allows you to identify common objects, people, text, scenes in images and video. We actually just released the full list of labels that it can recognize out of the box, and there's thousands. I did note, by the way, it claims it can recognize knitting and weaving. Doesn't have crochet. Obviously, I need to test this out. But the reason I didn't use it is you can't use it for custom domains, or you couldn't at the time. It could only recognize those things that have been pre-trained on. But we brought out this feature called custom labels, where you can build your own specialized image analysis capabilities and detect your own objects, different types of objects specific to your use case. So you don't actually have to train the model from scratch. It uses transfer learning. And you can get started with, according to the documentation, as little as 10 images. So I couldn't resist the opportunity to see how this compared to my experience using SageMaker. All right, so this is the Rekognition Custom Labels interface. You can tell right off the bat, this is a lot simpler than SageMaker, right? You got like 2 options. You got projects and you got data sets. As you can see here, I did this last April. I ran about 5 different, each of these projects is essentially a training job. And you can see the model performance there on the right. You basically create a data set and then you just click the button. You literally just click a button to train it and it does it. You don't have to do all that configuration. It will determine the best algorithm. It will determine all the hyperparameters it needs, and it'll just go off and do it. So here are some of the different data sets that I created because I was testing out different combinations of stuff. As you can see there, the number of images. I'll show you the results of a couple of these. So to create a data set, you actually don't even need to use an S3 bucket. You can drag and drop them into the interface in the console. But the convenient thing was I could actually point it at the labeled training data set that I used SageMaker Ground Truth with before. So it was super fast. If you already have a labeled training data set, you can just literally point it at it. So that was very helpful. And this is what it looks like in the interface. You know, as I said, you can drag in images. You can actually, it's actually got a little labeling interface in there. So, you know, if you drag in 50 of your own images, you can actually just label them yourself in the UI. You don't have to use Ground Truth as I did. So that was really nice. I could go in and tweak the labels on some of my data sets as well. And then when you click train, you see you get the, this is an evaluation of one of the projects that I did. You can see it's got some scores. It tells you I had 2 labels stuck in it or not stuck in it, 900 images. And you can see here some of the results. And I'll show you how to actually, how to demo this. We actually have on the AWS GitHub page some code. This is an Amazon Rekognition Custom Labels demo. If you scroll down on this, there's actually a CloudFormation stack. You can just click a button and it will deploy this application in your AWS account. It's very fast. So I didn't have to, get my little React app and doing the intermediary Lambda function, all that. Didn't have to do any of it. Literally was one button click and it created this app for me. This is what it looks like. It creates this nice little UI. It will automatically pick up all of the different projects that you have in your Rekognition custom labels in your account, depending on the region. And you can start and stop models for inference just by clicking on the buttons there. Pro tip, it does, when you click start a model, it does take several minutes for the model to actually be ready for you to start testing. But this is actually what it looks like. So this is the little interface. And so first thing I did, I tested it out with just 10 images to see how that worked. I didn't get great results. That's when I moved to using my whole full training data set that I did with SageMaker. But this is using that same data set. I dragged in here a picture of stuck in it, and it gives me stuck in it stitch. All right, how about garter stitch? Not stuck in it. This is looking good. How about our friend the cat? Not stuck in it stitch. So I actually found that using Rekognition custom labels, taking that exact same data set, creating a model with this, I got comparable performance. It still misidentified that one girl's sweater stitch, but it was basically comparable performance. And it took me like 20 minutes and 5 clicks to actually do this. It was so fast. The metric, it uses slightly different metrics to derive the performance. It's like the ratio of true positives to false positive, rolls those up into an F1 score. Not an expert. Basically, it's not a like for like comparison to the numbers you get out of SageMaker, but you get the idea here. We're looking at like 97, 98. Amazing. Way simpler. Way, way, way simpler. But wait, there's more. I was so blown away by this and that I got comparable results with like so little effort. I thought, hey, why don't I spend a little more time? Try and actually expand my scope, go back to trying to actually identify more than just stuck in it or not, trying to identify different stitches. So I spent a couple hours in that little interface, creating another data set and going in and actually relabeling different stitches for garter, seed, moss, and other. I left out reverse stockinette stitch because, again, even I can't tell that one apart. But after training that on the different stitches, so this is, you can actually just select a different model in the app to test out. So this is using that. So you can see here, it knows that this is stockinette stitch. It's got that correct. How about this is moss stitch? It actually distinguishes between moss and seed stitch. This is a rib. So it's actually identified this as other. So you can see it's got the V's that are in stocking stitch, but it mixes up the knits and the purls. So this is not stockinette stitch, and I'm actually really impressed that it got this one correct. So I've actually been able to go back and expand my scope out, and this is looking really promising. I'm still working on this. Just to sort of give you an overview of how these two different methods compare. So remember, we had Rekognition custom labels, which is that pre-trained up at the top. I gave it my training data, and it just does everything for you. Versus SageMaker, which is in that middle level where you have to, it does a lot of the heavy lifting. You don't have to roll your own completely, but you do still need a sort of lot of custom knowledge. This just shows you a little bit of the comparison here. Training time was one. Again, with SageMaker, you can choose what sort of instance your training job runs on. As I said, I work for AWS. I threw like some rather large machines at it. So it took 33 minutes. My hyperparameter optimization training job, I actually let that run for 13 hours. I think you can run it for, as long as you want. Rekognition custom labels, when you click the train button, it just goes off and does it. You have no control over it. And so the one I did, the comparable, the same data set here took 50 minutes. In terms of cost, that's one of the big differences between these two methods. SageMaker, you pay So the ground truth labeling job was the same. It was the same for each. There is a free tier for ground truth. You get, I don't think I have it on here. Oh yeah, you do. You get your first 500 labels in the first 2 months you use it for free. But it starts at 8 cents per labeled image for less than 50,000 images. That's not counting if you use Mechanical Turk. Obviously, if you're paying someone to label for you, that'll be more. But so basically, my training job for 900 images cost me about $80. Then the actual training of the model itself, you pay for provision storage, you pay for data transfer, you pay for the time running the instance. There is a free tier for SageMaker. You get 50 hours on an M4 extra large or M5 extra large. You get 125. That's for inference. For the free tier for training, you get 50 hours on one of those instances. But I added it up here, and you can see it's about $50 for training that I spent. I didn't run this on Spot. You can run these jobs on Spot instances. That can save you huge amounts. That can save you like 90%. I didn't do that on this particular one to give you the sort of maximum there. And then for inference, that's where you pay for storage, you pay for data transfer. That's where you're actually hosting the endpoint and running predictions against it. And so it's about $1.12 an hour for running my inference instance, plus storage and data transfer there. It's a lot simpler on the pricing side. Over on Rekognition Custom Labels, you basically got a flat fee of $1 an hour for training. But as I said, you don't really have control over how long that training job can run. One of my training jobs actually ran for 4 hours. And it will actually decide, it might not match clock time because Rekognition does this cool thing where it will decide how many instances to use. And so it may run multiple resources in parallel to train your model more quickly. And so, it might take 1 hour on the clock. That might equate to 2 or 3 hours of instance time behind it. But we do see that like 90% of the models need less than 24 hours to train. If it goes on longer than that, if it hits 72, it will automatically shut down and you won't get charged for that. Inference is where you pay a lot more on this one. You pay $4 an hour flat fee for while you have those models running. So this is not something where you want to turn it on and leave it running 24/7 to run your predictions against. You want to turn it on, run a bunch, and turn it off again. That's where Rekognition Custom Labels really shines. If you're building something where you want it to be on all the time, then maybe you want to use SageMaker. But ultimately, that last line, like the last 2 boxes here, I got comparable results, and Rekognition Custom Labels was so much easier to use that for a non-expert, I can't help but recommend it. It's so simple. And you don't have to take my word for it. This was a blog post last November from one of the AWS heroes, Luca Bianchi. He's in Milan. And so Luca did the same thing I did. Luca had built out a model with SageMaker, and then he compared it. His use case was like snapshots of heating and ventilation systems to check cleanliness and air quality. And so he had a data set of like 2,300 images. He got them labeled. He's a bit of an expert. He used PyTorch. He used the Fast AI library. He deployed a model on SageMaker, and he got accuracy of like 92%. So then he took that same training data set, did exactly what I did, fed it into Rekognition Custom Labels, and found that it gave comparable accuracy without needing the help of a data scientist. I think he calls it like he's pretty shocked in this blog post as well. And this, incidentally, this is kind of the perfect use case for something like Rekognition Custom Labels, because, you can actually just spin up the model for inference, batch up all your images and run them through, and then shut it down, which will help optimize on the costs. So I'm coming up to the end here. I just want to give some thank yous. 53 knitters around the world sent images to me for my training data set. Maybe some of them are watching right now. 14 humans collectively spent nearly 15 hours labeling and clicking more than 3,000 buttons to label all these images. And I also benefited from advice and guidance from some of my colleagues, Gabe Hollenby and Aparna Langvan. So this is what we covered today. I talked to you a little bit about the state of AI ML, some of the cool stuff that's happening. Really look up AlphaFold and DeepMind. As I said, you can check out their source code and look at some of the predictions for human protein structures that they're actually now making public. Talk to you about art and cats and getting pizza to people faster, which is really all that's getting me through this time that we live in right now. I pointed you to the AWS ramp up guide for machine learning just as one way of getting started. And remember, if you Google AWS Innovate, that was our recent AIML conference. You can actually see some of the videos online if you want more examples from people who are experts in this stuff. I gave you a little overview of the stack at AWS, as I said. And I know other providers have similar tools where you've got pre-trained models that you can just use out of the box just by calling APIs. We have SageMaker that across the middle, where if you know a bit, you can really have a lot of control over how you train and deploy your models. And then, of course, we've got those foundational services around the bottom for machine learning experts and data scientists who want control over every aspect of their machine learning workflow. And then I walked you through my knit ML project to try and teach a computer to recognize different knitting stitches. And I'm actually really pleased with how this is going. So I've after descoping it down to just stockinette or not, I've gone back up to being able to identify multiple stitches. So now I'm going to continue on with this. And my new project is to see if I can actually use a photo to count the number of rows, because I'm lazy. And when I'm knitting, I just want to take a picture and have it tell me how many rows I've knitted. So that's the next iteration of this project. All right, I think, I don't know how much Q&A time we have, but if you would like to ask me questions for Q&A, we do have Slido here, and you can jump over to there. But Lars, you're back.
Hello.
Hey.
Hey. Yes, I'm back.
Oh my
yeah,
gosh,
so
I finished my coffee. It's getting cold here.
Yeah, I finished mine. It's right there in front of me. You I think you just mesmerize people. I find it fascinating, the ML world, I think. So I used it recently. I think I used it anyway. Google has a feature on the Android phone called Google Lens, I think it is.
Yes, I've used that for translation here in Germany.
I've used that for trees, because we have a bunch of trees and I live in a farm, and one of them had died, and I was wondering why it died, and I tried to recognize it. And I recognized that one on the leaves, which I thought was kind of cool. And I now know I have an Algerian oak tree. There you go. But you could also use the bark. So it was all different things that it would recognize it on. So I thought that was kind of useful. Like you said, hey, laziness solves many things, or encourage you to solve many things, right? So
there's so many examples of, like, when you see a lot of these talks, it's like, now we will predict the cost of housing. And it's like, ugh, that's not interesting to me. No. Identifying a tree, that's cool.
Sorry. Recently, I'm a total Lego nerd, right?
I saw your video. Your video
went. You did?
I did, of course. Everybody was talking about that.
It was amazing. There's an app called Brickit, and you just take a photo of your pile of Lego blocks, right, which are on the floor, and it figures out what you can build from them. It's amazing, and it doesn't have to be the right colors or anything. It's quite, and it's like a beta. It's really early thing. Yeah, I did have to use an Apple device to run it, but we'll gloss over that. So yeah, I was amazing. It was just so good. The whole there's a question about where can we get knitML?
That's a good point. I can put my training. I actually have not made
GitHub?
My training data set available, but I will. Absolutely. You're right. I crowdsource this. I should make it available. I don't know why nobody's asked me that before. I will put it up on my GitHub. If people want to play with it, I will absolutely do that.
Okay.
I mean, there's no real code for it. I did it in the console.
That's right.
But I can also I'll tweet out the URL to that Rekognition Custom Labels app.
Yeah, do that.
I'll do that.
That'd be good. There's so many applications on there. I've set up a camera that just films my llamas, right? And it's just streaming online. But I wanted to use machine learning to tell people when there is a llama, because most of the time there isn't one, because it's a big paddock.
That's why we're tweeting about llamas.
I know. And I haven't quite finished it yet, but basically I have a model that will tell you whether it's a llama or not. So if there's, something in the picture, it'll tell you if it's a llama or not. It even recognized it wasn't a llama when it was an alpaca. I thought that was impressive. And again, I didn't do any coding. That's all just machine learning, right? So,
well, I am working on another project, sneak preview for reInvent. I'm working with a couple people on a beer recommendation engine. Because, in the old world, we would go places. Yes. So see, you'd travel places. You'd be in another city and you'd be like, I wonder what local beers I would like. And, I've got hundreds of beers in Untapped, Why can
Yeah,
I
yeah,
not
yeah.
actually get myself a prediction? So a few of us are. I'm working on this. We'll see how we
Oh,
go.
well, Germany is the perfect sample market.
Exactly.
Yeah, absolutely.
Yeah.
Oh, wow. So much goodness.
Yeah.
Oh, that's
Beer and
awesome.
pizza and art. All the important things in life. And
cats.
alpacas. Yeah.
Thanks so much, Kris. That was really good.
Thank
I
you.
genuinely enjoyed that. That was, and I'm not a knitter, but yeah, it's just the application of a real world thing onto something that's a bit more abstract. Just really makes it come to life, I think. So that's all we have. I think from Kris Howard. Unless you want to add something at the end, where can we see you next, Kris?
Oh gosh. Do I have any
Reinvent?
Aussie? I mean, the good thing is because the time zones, I'm still getting to do the occasional Aussie thing. Probably Reinvent will be the next big one. I'm guessing. Yeah.
That sounds good. Look
Oh,
forward to that as well.
Femtech Conf. Femtech Conf is coming up. I'm speaking at that one. It's a conference online for women in tech. It's really it's a global one. I'll tweet that out. Please, people, come to that one. It's going to be pretty good.
I can't go then. No,
you're
that's
allowed
awesome.
to watch. Come on.
Yeah, okay then. No, thank you so much, Kris, and thanks for joining NDC Melbourne. And
miss you all. I can't wait to see you again. I can't wait to visit.
Alrighty.